Hello everyone, thanks for watching my screencast today on arithmetic sums part 2. In this video, we've already learned how to find the sigma notation of an arithmetic sum. Now we're going to actually use a formula on how to find the arithmetic sum if n is large. So yesterday we learned about arithmetic summations. Today we're going to practice finding summations of various sequences, arithmetic and non-arithmetic as well. But be careful, this following formula that we're about to look at here is only applicable if the sequence is arithmetic. So, if the sequence is arithmetic, the sum of the first n terms would be the amount of terms divided by 2 times the first term plus the last term. If it's not arithmetic, we don't have a formula for it. So you just got to find all the terms and add them together. For now. Number 1, consider the sequence a sub n equals 5n minus 3. All right, first, let's find the first 5 terms. First term would be 5 minus 3. It's a sub 1. The second term would be 10 minus 3. The third term would be 15 minus 3. Fourth term would be 20 minus 3. And fifth term would be 25 minus 3. Increasing by 5. Clearly this is arithmetic. It's a linear sequence, so clearly this is arithmetic. So, find the sum of the first 5 terms. We can do this in 2 different ways. Now that we've already had these 5 terms written out, we can just add them together, right? And we write this like this, s sub 5. And if we add these all together, we would get, let's see, 39, 51, plus 9 is 60. Using the formula, we could have did s sub 5 equals 5 over 2 times first plus last term, which is 5 over 2 times 24, which is 5 times 12, or hey, look at that, it's 60. S sub 20. Now this one, we definitely don't want to do this method where we just add them all together. We want to use this method. So we got 20 over 2 times first term, which is 2, plus last term, which we don't know yet, but we could find it pretty quickly, right? So a sub 20 will be 5 times 20 minus 3, which is 100 minus 3, or 97. So that would go right there. So that would be 10 times 99, or 990. You can see much easier to use our formula than it would have been to actually find the first 20 terms and then add them together. That might have taken us a while. So next one here says to find the sum of the arithmetic sequence. All right, so we know the first term is 5, and we know the last term is 71, but we don't know how many terms there are. So to do this, we probably should write out our explicit formula. D here being 6. There's our explicit formula. We set 71 equal to that. I don't know why I put D here, it's supposed to be an N. I'm sorry about that. If we set 71 equal to that and solve, we would get N equals 12. So there are 12 terms in this sequence, which means the sum of the first 12 terms would be 12 over 2 times 5 plus 71, which is 6 times 76, which is 456. Number 3. In an arithmetic sequence, we have 2 terms. They're find the sum of the first 70 terms of the sequence. Well, again, now the first thing we got to do is find the nth term. So I have 2 equations here. I have 31 equals, we don't know the nth term here, but I do know that the 12th term would be 31. So I can do a1 plus 12 minus 1, which is 11d. And then 23 equals a1 plus 28 minus 1, so 27d. All right, and if I subtract this, I can get 31 minus 23 is 8. The a1's cancel. 11 minus 27 is negative 16d. So d is negative 1/2. And if I put that back into either equation, let's use this one here, I get 31 equals a sub 1 plus 11 times negative 1/2, so that would actually be minus 11/2. Add 11/2 to both sides. Let's see, that would be 36.5, or 73/2 would be a1. So now I can write my nth term out as a sub n equals 73/2 plus n minus 1 times d, which is 73/2 minus 1/2 n plus 1/2, which is 74/2, or 37 minus 1/2 n. So that would be our nth term. So we got to find the first term, which we have, and the last term. So it would be a sub 70 would be 37 minus 1/2 of 70, so 35. So that'd be 2. So now my sum of the first 70 terms would be 70 over 2 times 73/2 plus 2. All right, I'm going to go to my calculator for that. 73/2 plus 2 times 35. The sum of the first 70 terms would be 1,347.5. Okay, number 4, given an arithmetic series with s sub 25 equals 100 and a sub 1 equals -4, write the explicit formula for the sequence. Okay, so we have this. A sub n equals -4 plus n minus 1 times d. We don't know what d is yet, okay? But we do know that for sure, okay? We also know that the sum of the first 25 is 800. So I can set 800 equal to 25 over 2 times the first term, which is -4, plus the last term, which we don't know. All right, but now I can use this to find the last term. All right, so if I solve this for a sub n, I can multiply by 2 and divide by 25. Now we get 64 equals -4 plus a sub n. So 68 is a sub n. So the last term is going to be 68. All right, so now I can say 68 equals -4 plus n minus 1 times d as well. But let's remember what else we know. That 68 is the last term, and we're talking about having 25 terms here. So really, this a sub n is a sub 25. Right? And over here, I can put 25 in for n to get this, which means d would be 3. So now I can take this equation here and put 3 in for d. -4 plus 3n minus 3. 3n minus 7 would be our explicit formula. All right, number 5 says find the first 3 terms of the arithmetic sequence, given that a sub 1 equals 14, a sub some number k equals -85, and s, the sum of the first k terms, is -1207. So let's just start with what we know here. I know a sub 1 is 14, right? So when I write my equation out here for the nth term, I would get 14 plus n minus 1 times d. I know a sub k equals -85. So -85 would equal 14 plus k minus 1 times d. I know the sum of the first k terms, so s sub k would equal k over 2 times the first term plus the last term, so 14 minus 85, 14 plus 85. And that's going to equal negative 1207. All right, so now we can use our algebra skills to solve that last equation for k. So I'm going to multiply both sides by 2 and get negative 2414. And then this would be negative 71. Divide 2414 by 71, and we get k is 34. So now we can put that number back into here. We get negative 85 equals 14 plus 33d. So negative 99 equals 33d. Negative 3 equals d. So now my nth term can be a sub n equals 14 plus n minus 1 times negative 3. Or if you want to simplify that, 14 minus 3n plus 3, 17 minus 3n. So now we can find the first three terms pretty easily. The first term we already got was 14, given to us. The second term, if you put 2 in there, you get 17 minus 6, which is 11. And the third term, 17 minus 9 is 8. Number 6 says find the first three terms of the arithmetic sequence. If n is 16, a sub 16 is 15, and s sub 16 is negative 120. Okay, so if I know a sub 16 is 15, we can write 15 equals a sub 1 plus n minus 1, which would be 15, d. And if I know s sub 16 is negative 120, I can write negative 120 equals 16 over 2 times a1 plus a sub 16, which is 15. Okay, solving that for a sub 1, I would get negative 120 divided by 8, which is negative 15. Subtract 30, a sub 1 must be negative 30. Put that back into here. We get 15 equals negative 30 plus 15d. So 45 equals 15d, and d is 3. So my nth term now would be a sub n equals negative 30 plus n minus 1 times 3. Or a sub n equals negative 30 plus 3n minus 3. Or finally, 3n minus 33. So now the first three terms, if we put 1 in there, we would get 3 minus 33, which is 30, 6 minus 33, and 9 minus 33. There's our first three terms. All right, number 7, consider the arithmetic series. Find the sum of the first 25 terms. So let's first write out the nth term, right? We got 20 plus n minus 1 times negative 2, 20 minus 2n plus 2, 22 minus 2n is the nth term. So we have s sub 25 would be 25 over 2 times the first term, which is 20, plus the last term. We don't know the last term yet, but we can find it by doing a sub 25 equals 22 minus 50, which is negative 28. So we get 25 over 2 times negative 8, which is negative 100. Now it says find n such that s sub n would be 108. All right, so we got 108 equals n over 2 times a sub 1, which is 20, plus a sub n, which we don't know what that would be quite yet. Okay, but we do know that a sub n 22 minus 2n from our part A. So now we just simplify this and solve it for n. So multiply both sides by 2, we get 216 equals n times 42 minus 2n. 216 equals 42n minus 2n squared. Bring everything over here. 2n squared minus 42n plus 216 equals 0. So n squared minus 21n plus 108 equals 0. All right, now we can try to factor that. So factors of 108 that add to 21. Let's see if we can find something like that. I think it's 12 and 9. So we have n minus 12 and n minus 9. So n equals positive 12 or positive 9. So actually, there are two different times when this sum would equal 108. When there's 12 terms or when there's 9 terms. Number 8, in an arithmetic sequence, if a sub 1 equals 16 and a sub 13 equals 98, find s sub 13. So if a sub 1, let's start with our basic formula here, 16 plus n minus 1 times d. If a sub 1 equals 16 and a sub 13 is 98, so 98 equals 16 plus 12d. So 82 equals 12d. (41 over 6 would be our common difference. So now, if I want to find the 13th term, well, first let's write our nth term out. So 16 plus n minus 1 times 41 6. If I want to find the 13th term, I'll put 13 in there. So, we already did that. Never mind. We got 98 already. So now we're going to go ahead and find the sum of the first 13 terms. So s sub 13 would equal 13 over 2 times the first term plus the last term. Let's see if we can put this in our calculators. 13 over 2 times 114 equals 741. I guess all this work was actually unnecessary here. We didn't need to find the nth term, the explicit formula at all, so could have just jumped right to here. But that's okay, extra practice. Number 9, if a sub 12 equals negative 1 and d equals 3, find s sub 50. All right, so a sub 12 equals negative 1. So negative 1 equals a sub 1 plus 11d. And d equals 3. So negative 1 equals a sub 1 plus 33. So negative 34 would be a sub 1. So now I can write my equation out. A sub n equals negative 34 plus n minus 1 times 3, which is negative 34 plus 3n minus 3. And finally, 3n minus 37 is a sub n. So then the 50th term, well, let's find the first term first, I guess. That'd be 3 minus 37, or negative 34. We already got that. And then the 50th term would be 150 minus 37, which is 113. All right, so now, sum of the first 50 terms would be 50 over 2 times first term plus last term. Let's go ahead and type this in our calculators. Sum of the first 50 terms would be 1,975. All right, to this point, I would suggest that you pause this video. There are 2 problems left on the last page. Try those last 2. When you're done, unpause the video and check your answers. Here are the answers to the last two problems on the last slide. That'll do it for our video today on the summation of arithmetic sequences. Thank you very much for watching, and I'll see you again soon.